speed of sound minus your velocity that you're observing them at, yeah? Yeah? Okay, so this one's actually, I think, a simpler derivation. So for moving observer, I think it's that the frequency you hear is equal to your speed, the speed of sound, plus the observer's speed divided by what the actual wavelength is. So that's the actual wavelength. That's the speed of sound. That's the observer's speed, right? And of course, this makes sense if you're not moving, right? The frequency, yeah. And then what am I going to do that? Am I going to do the same exact thing? Yeah, I'm going to multiply the top by the original frequency and the bottom by 1 over the period. Let's see where that takes us. Okay, so then we go frequency, the shifted frequency, the new frequency is the original frequency, right, times V plus U of the observer. And then what is lambda divided by period? Is that just the speed of sound? There we go, right? Okay, so for moving observer, the shifted frequency is the original frequency times the speed of sound plus the observer's velocity over the speed of sound, right? So this guy, this is the speed of sound. And you could use 343 meters per second. Let's do clever things like tell you that it's underwater or that the temperature of the air is 85 degrees Celsius or something like that, right? Okay, very warm air. Okay, so there's that. And then this guy, the UO there, is not the University of Oregon, but it's observer velocity. And then, of course, this guy's a plus or minus. Which one's which on this one? Which will give you the approaching frequency, which will give you the receding? Approach is plus and recede is minus. This one's straightforward. Plus makes it bigger, since it's in the numerator, right? Minus makes it smaller, right? So in this case, plus is approach, minus is recede. Now, isn't it different between the two? The best, the most robust thing to remember is this, right? If you don't know which one to calculate, do them both and then decide which one you're going to do. Yeah? You're going to use. So let's do a couple of these and I'll have you guys try them. Okay? Let's suppose somebody's got a car and it puts out an A440. Right? That's the actual frequency, the unshifted frequency. So in the car wasn't moving, right? That it puts out a perfect A440, right? Okay? Yeah? Let's all sing A440. What is it? Da. Is it da? Da. I've totally... What's it doing? Oh, it's sine pulse. Duggan's like messing with me. Da, da, da. Again, a whole step high. I've got perfect pitch. But you got to subtract the whole step. So it's putting out that frequency. That is the real frequency. If the car's not moving, that's the frequency you'd hear. Okay? And then let's suppose the car is approaching us at 27 meters per second. Okay? Approach. Right? And we're standing on the edge of the road and it comes toward us and then it goes by us. What do we hear as it approaches? What do we hear as it recedes? Now, is this moving source or moving observer? Moving source, so we decide that. And if it's approaching, should it be higher or lower?
Lower.
Higher. Yeah. Right? So you're going to hear the high pitch first, low pitch later, right? So let's go. Let's just work this out, right? So the frequency is going to be the original frequency times the speed of sound divided by the speed plus or minus the source, right? Yeah? Plus or minus, right? So let's just plug this in. For approaching, the frequency is going to be 440. And then let's assume it's 343 for the velocity of sound, right? And then it's going to be 343. And then for approach, we want a higher frequency, correct? So we better make the denominator smaller.
Wait, wouldn't the 440 go on the original?
Yeah.
Not
Oh, smart aleck, yeah. Only I drew the formula wrong, so this guy's the prime. Sorry. Yeah? Are we good now? Confused, but better, right? Okay, and then we are approaching, so don't we want a higher frequency? So we do the minus, right? Minus 27, right? And then this, of course, has to be in parentheses. All right. 343 divided by parentheses 343 minus 27. Take your calculator and do that. Calculate along with Mr. Murray. You have to put this in parentheses, so you times this divided by this in parentheses. Right? Sure enough, I get a frequency of 477. Right? 477. So as it approaches, instead of we hear 477.59. And then as they go by, what's it going to be? Can we just, by the way, subtract apparently the shift of, does it work to just subtract 37 from this? It's going to get us in the ballpark, but it's not exact, right? So let's do, this is the approaching frequency. Right? And then let's figure out the receding frequency. The shifted frequency will be 440, right? And then it's 343 over 343 plus, yeah, there we go, 27. Ta-da. So again, I'm just going to go second entry because I'm so lazy. I'm going to change that minus to a plus because I did it in one swell foop. 407.89. Is that 440 minus 37? Is it? It's close. It's in the ballpark, but it's not, right? It should be like 403 if it were, right? But it's not. So you can't just go, you know, you can't just do math like that. You get the ballpark, right? So this is what we hear. It goes from this 477, and then when it goes by, it really was this. And as it goes by, we hear, what is it, 407.89? Yeah? That's kind of cool, isn't it? As it goes by, right? Okay. Now, let's suppose, let's do another scenario here. Okay? Let's suppose that car parks on the side of the road, and you guys get on your, you run by it at 27 meters per second, nearly freeway speed, right? But you guys are fast, aren't you? Yeah? Yeah. So now let's have you sit still, okay, and have you go by, right? So you're going to ride by. Here's the car parked on the side of the road. Right? It's making all this sound, right? And you get on your motorcycle, right? And you go, the car's sitting still, and you go biking, and you approach it, and you go past it, right? Because you're just tired of them sitting on the side of the road, right? So is that moving source or moving observer? That's now moving observer. As you approach, which one do we use? Well, we know it needs to be a higher frequency, correct? Okay, so, you know, definitely the plus, right? Okay, so I'm going to plug that in as we approach. Okay, then the shifted frequency is going to be 440 times, and then we have to go 343 plus 27, right? Divided by 343. Are we going to get the same answer? Are we going to get the 477? Do you think it'll be the same? I know, it's like, it's close though, 343 plus divided by, that has to be in parentheses, divided by 343. 474. Remember the other one was 477? So again, this is a higher frequency because it's approaching, and when it's approaching, it's always higher, or you're approaching it, right? But it's not the same number. It's very close. That's why when we grade this skill set, one of the things they've got to do correctly is decide whether it's source or observer, right? Don't say, oh, well, you got really close. The answer was 477, but you must have gotten it right. No, they didn't get it right. That's why I'm giving you like 3 sig figs on all of them. Make sure that they're using, when you grade it, that they're using the right formula, right? Show your work too. Yeah. Oh, this is hertz.